Welcome to Quo Vadis. I'm pretty amazed to see the turnout. It's also been pretty amazing to see the number of requests for access to the Google Drive. Trying to exploit this new technology to get all your talks and presentations and quad charts in. So I will, if you haven't submitted them yet.
Your name is on the wall of shame right here if you haven't submitted them yet.
Including mine.
Including his. So see me if you haven't submitted it.
Or email him.
Or email him.
It didn't, what was my name? Was it spelled right?
I thought that password should be something spelled.
Oh, no. So the Wi-Fi password is here for those of you, it's just UCAR guests. What you'll notice, we'll move it somewhere more visible.
Over here.
All right. Is they have this cryptic, quasi-random thing. It's not really random. We're not quite sure if it's random or not. So logistically, HAO welcomes you also. HAO is housed about 400 yards that way, across under the underpass, and over that way. Unfortunately, our building was too busy. It was booked up long before we had the chance, or we would have had you in our homeland. Trying to think, there's restrooms just outside here. Actually, they're that way. The cafeteria is over here, right behind me, where you all have lunch, of course, that you'll be paying for. Or you can go elsewhere. I think there's one more item that I'll put up at lunchtime, is that I would like to invite any of you that are here for one of your favorite beverages at the Centre Green Pub, CG0, also known as the Boulder Brew Pub, which is about 700 yards that way. And I'll put up logistical information about that at lunchtime. And I hope to see some of you, if not all of you, there for a pint later this afternoon after we're done. And so with that, I guess I'm chairing the first session. And I'd like to welcome Teresa Moretto-Jorgensen of the NSF to come and, oh, is it Dave first?
No, she's...
No? Okay. See, I'm failing already. To come and I'll welcome Teresa and to give us our kickoff of where are we going.
Thank you. Thank you. Well, thank you. Can you hear me? We are nice and cozy in here, so maybe I don't even need the mic. I'm good at yelling. So first, let me say how grateful I am to the organizers for getting us all here, and to all of you for showing up and offering your support. What we are embarking on here with this workshop is a really important effort. We need to identify the most exciting and most promising frontiers in geospace science from the perspective of ground-based observations. And then we need to determine from that some future directions that we can all get excited about. So that is where we go from here part, and therefore the name Quo Vadis. Now, it can be very risky and scary to be at the frontiers. So I could imagine that many of you have been asking yourself these questions. Why are we here? Why are we put here? And what is it exactly that you want us to do? And I'm not sure I can fully answer those questions for you, or at least satisfactorily. But I will give you my thoughts, a few of my thoughts on those, and hope that will boost and stimulate the discussion over the next few days. At least I think that was what I was asked by the organizers to do. So why are we here? Well, at a very basic level, this is the nature of scientific progress. Here in the words of one of the fathers of experimental physics, some of you may have heard of, and he says, to do new things, to see new things, you have to do new things. Basically, that's it. And now, pushing the boundaries of what we can measure and how to do it better, that's, of course, what you all do every day. So the reason we have brought you here is so that you can share your visions and we can exchange ideas and then build consensus and excitement and support for those new things that we determine we need to do in geospace science to stay at the frontiers and to push the frontiers. That was easy, right? Next question you might ask, well, why now? Well, now is a good time. And here I give you just one reference point that is relevant to that. We're approaching, and that may come as a surprise, it did to me actually, we're approaching 10 years since start of operations of our new AMISA radar installation at Poker Flat. So what is the new big leap in technology or in capability that we would like to see? And how are we going about making it happen? That's one of the reasons we are here, is to try to start answering that question. But also increasingly, geospace science is about questions that concern not just a more detailed understanding of the physical processes involved. We also now ask questions that concern the large-scale dynamics, coupling and interactions. And this kind of system-level science drives a need for continuous observations from dense, widely distributed or even global networks of instruments. And so another question is, how are we going to accommodate this kind of new observing systems into our programs? That's another good reason why we're here and why it's right now. Another reason that the workshop is timely right now is that it builds on several community reviews and planning efforts. The decadal survey, which sets the context for the large overarching science challenges that we are pursuing right now. And the Geospace, the portfolio review for Geospace, for the Geospace Science section at NSF, that provides a really detailed inventory and an assessment of all the activities that we support in the section. And also make some suggestions for future adjustments, in particular on our ground-based observing program. So we can build on that. However, I will also add to that, and I didn't put it in the slide, it was a thought that should have occurred to me when I put them together, but didn't. Because right now there's another really good reason, and right now there's a renewed, strong awareness at a national level that space weather is a potentially devastating hazard that we need to understand much, much better and be much, much better prepared for. And figuring out how we position ourselves to, in the best possible way, to help address this national need is another really good reason why we're having this workshop right now. So what is it we need to do? What I hope we get out of this workshop is, first of all, a comprehensive picture of all the great ideas that are out there, and that we start to form from that picture some future directions that we are all excited about and can get behind. And one important part of that is to look for synergies as we listen to each other's ideas. Look for synergies, sometimes combining things, we can combine things for bigger impact and better effect. But it's also to clarify those areas where there are competing needs and pressures so that we can determine what does the future good balance for the ground-based observational program in geospace science look like going into the future. So the question of balance is going to be really important. And one aspect of the balance issue is the one I already alluded to, that there's sometimes competing needs between the physical process-oriented research and the system-level type investigations. The latter needing, as I already said, these global distributed networks of observations, and that then is in competition with us also needing facilities that are localized but provide comprehensive and ever more detailed and accurate measurements of the processes. So finding that balance is going to be key, and finding it and doing it right. And lest you should think that this is just a battle for the upper atmosphere part of our science, I put on the example of DKIST. Dick is coming online soon, really, really exciting. It's going to give amazing measurements. But it also does put a strain on our ability to maintain and advance our capability for synoptic measurements of the sun and corona. So the balance question is really generic and is one we should look at carefully. As we look for solutions, it's also really important to be aware and take full advantage of new technology developments. That's another reason we're all here, so that we can share our ideas for that. And it's not only to build more capable instruments, but it's also potentially to do more with less. So we should look for ways to maybe build simpler instruments, more robust instruments, autonomous systems that can be more easily deployed in large numbers and in all parts of the world to create global networks. And that's basically what the DAISY concept is again. Another thing we should make sure to take full advantage of is the interconnectedness of the world we live in now. How are we, as a community, best making use of concepts like the Internet of Things, or big data, or public participation in science, where people with their smartphones can maybe make measurements and provide us observations, or collect and share data for us, or even process data for us? New, exciting concepts that we should take seriously and look into. So with that, I think my opening remarks is simply to encourage all of us as we go through the next few days to be broad-minded, open-minded, think creatively, and to dare be enthusiastic about and supportive of ideas that may be unusual and, more importantly, may not be your own. And I want to end with a tribute to my good friend and new colleague at NSF, John Merriweather. He really carried the torch for this workshop, both at NSF and I think in the community, since the idea was first formulated. And now I've also learned why he finds the name Quo Vadis so highly inspiring. And I am going to share that with you all. But first, I think we should make a pledge right now, before the workshop starts, that we're not going to let John down. We're going to make this just a spectacular success, just as he envisioned. And here's what he envisioned.
3 years in the making.
Okay, it's not very loud, but it is very inspiring.
You'll never forget its unequal spectacle. You'll always remember its heart-pounding drum.
I really had envisioned this for the Center Green Auditorium.
Thank you. That's something to really live up to. Can we have Ben Hur next? Let's just get the chariot races rolling. And so we'll proceed with Josh Simter of BU, who will prime the pump somewhat on the state of the game and all the various political alignments and community alignments that have taken place over the last couple of years. Thanks, Josh.
Thanks, Scott. All right, so I'm always about 4 feet above the microphone, so luckily I won't need it anyway, but that was really inspiring. Thanks for showing those slides and giving us that presentation. I guess in a bit of role reversal, I'm going to say a few things that are more on the programmatic level, and as is Mike Wiltberger after me. And I think one thing you'll hear from me and everybody else, including Dave, when he gets down to giving his charge, is that we'd really like everyone's help in trying to figure out some way to make this different than a normal science dissemination workshop. I mean, any way that we can get that to happen would be really fun, I think. And so things like interruptions and ideas that are totally off the wall, I think, just pretend it's a closed door meeting and we're all off the record. That would be really useful. I think the pints should come earlier. That would really help if we could get them. But,
I'm not open yet.
oh, all right. So, So it turns out that we didn't actually coordinate so well. The conveners are sort of presenting things here in the opening session, but it looks like just reviewing things at the 11th hour there, we actually all sort of agree on what this meeting is, right? Maybe to the 80% level. So I'll give you my view on this stuff, and I'm happy if you totally disagree with my perspective. But I'm going to try to keep things at a level of absurd generality, except for this part. So along with my co-conveners and other people in this room, I've had the pleasure of being involved in several strategic planning exercises over the past years. The decadal survey, I was down there at the panel level. Dan Baker and Tom Zerbukin led that effort. The Geospace portfolio review, led expertly by Bill Lotko. I was involved with that one. And then there's a nice dynamic Earth document at the NSF at the geo level that came out, where if you go and search space in there, it shows up about 10 times, and about 6 of them are actually about the space that's above us. So it's in there. Then, of course, what Mike is going to talk about a bit is the space weather strategic strategy and the space weather action plan that came out of the White House. And it's interesting, the timing, of course, because that document developed during the period when we were doing the portfolio review. So they were sort of cross-informing each other as they were coming out. And heliophysics roadmap, we may as well mention NASA just once, right? And then there's been other facility advocacy documents that have come out that have actually been really, really good. Cosmo, which is a real synergistic idea, as is OASIS. DAISY is now years old. I guess, how old is DAISY? Maybe that document is probably...
Josh, I first briefed NSF on that in 2002 with John Foster prior to that workshop. It came out of a lot of stuff we were doing at the time.
Yep.
Then it kind of morphed. Once we had the workshop in Woods Hole, and that then gave it the impetus to make that NRC document. And then people have done small efforts.
Yeah. Yeah, that's right.
The time wasn't right, actually.
No, but the fact that that document is in place, I hope everybody takes that as a lesson that, we actually, it turns out we live several decades. And when you make a document like that, it can resurface. And I mean, DAISY is now becoming a improper noun almost in our field. The CEDAR New Dimension document, Jeff Thayer led that effort. That was interesting. Maybe you could summarize that document in 2 words, system science. But we always write, we need documents so you can put on the coffee table, so it's okay that it was longer than that. So what's missing, I think this is roughly where we're heading, a unifying strategic plan for geospace facilities written for people who do not do geospace research. So one thing you'll hear is that, and I totally agree with, we spend way too much time talking to each other. And ultimately, I don't mean we have to make a document for, your 8-year-old son or something like that, but a document that's written for a technically competent audience that's not us is really important. And I don't know if we're all that good at doing that. So just take one of those documents, because this is probably the most relevant and important, the Geospace Portfolio Review. It's difficult to summarize that 180-page document in one slide, but here it is. We're assuming the Geospace section will maintain flat budget of roughly $45 million a year. The recommendation number 1 is to maintain all the science core research that we do in the program, and I think that has 100% buy-in. Then there's some new money that's potentially realized through reduction of funding to large facilities, and by forging international partnerships, for instance with ISCAT, and revamping the CubeSat program. There's some discussions about how to do that with NASA and other stakeholders. So if there were free energy, and it can't be all that much because it's really, we're 1.3% of the Geo Directorate budget. We're really small, and we do amazing things with that small amount of money. But the new program elements that were recommended, grand challenge projects, data systems, DAISY, and then something about innovation and vitality. And the bottom line here might be, insofar as this meeting is concerned, new large-scale facility investments can't come from that budget. Anybody disagree? All right.
Can you say something about bit scale? I mean, is this the decadal survey pushed bit scale, and I think that's what we're lacking, and that's what...
Let's see. Let me just skip to that one then. And okay, since you mentioned it, right? So, in a way, there's 2 options on the table. status quo is that we have the funding sources, including the one you mentioned, right? So we ratchet up. We all do 100K a year per institution sorts of budget proposals. The MRI up to 5 million, cross-cutting stuff. So this is where we can find a lot of, we have actually been really successful at finding money for our research. I think that this is really interesting. Inspire, FESD, Colorado had a good one there, as did UNH under Harlan Spence. Prevents, we're thinking about how to do that, right? EarthCube, I don't know how active we've been. I think the MIT gang has had some funding there. And then one-off centers, SISM, it's hard to tell if we would get another one given that we had one. And then the occasional mid-scale sort of level project like the A-Misers. And that may be fine. I don't know if this addresses your question. I just thought maybe it might. And then, a new opportunity might be, well, given that the White House is interested in space weather at a very high level, and given also that when you go out into the community and you ask people, like if you gave a list of things and said, you asked your Uncle Bob, what is geospace? He's not going to know. If you ask him what space weather is, he's going to know, quote unquote. Everybody has an idea of what that is. So the fact that this is gaining traction at a public level it bodes well. And maybe this is the time when, not to talk too much about where Dave's going to go with his chart, but maybe this is the time to think about $100 million level projects that we could put together to implement something like the research arm of the Space Weather Program. And that was this bullet here. Can the solar, mag, and astronomy communities coalesce around a single project description that implements the research arm of the National Space Weather Program? So that might be one binary sort of question to ask. And but so that, it takes me a little bit out of order here. But this is related to what I just mentioned, right? This picture here is like a level that a lot of people in the world could understand in terms of describing what we do. And then what happens, though, basically there's a force on the magnetopause that does a few things. At one lower level of complexity, we might be able to understand the tangential force as differentiated from the normal force and what that might do. But eventually you get to this multi-scale Rube Goldberg machine that we tend to draw, right? This is, we go from here and then we go to there, and that's a little bit problematic in terms of engaging the public imagination. So can we create compelling science questions that unify the entire geospace community, have demonstrable societal relevance, and engage the public imagination? I think that's a useful thing for us to think about. Now here's a thought. I don't know what people think about this, but this is sort of my own feeling, is that, okay, great, we have space weather, and if the definition may still be a moving target, even in light of the strategic planning documents that have come out of the White House. And in my thinking, you could grab a lot of things under that umbrella. Effects on power systems were already there. Effects on communications were there. Navigation were there. Human survival in space is not often talked about. If you look at those documents, it's mentioned a few times, but it's not a big deal. But if we want to be the people that solve the problem of how to keep people safely in space for 5 years to go to Mars and things like that, I mean, that's perfectly in our wheelhouse, right? And that could be space weather. Space debris monitoring could be part of space weather. Even asteroid impact. I mean, if I were to go tell Uncle Bob about space weather, I might include that. Like, we're the people who also think about objects that might take out the human species. And then discovery. That's the whole thing. Once you get this is operations to research, in a sense, right? Once you get all of that operational stuff in place, and discovery is going to happen, that's what we all really want, I think. So I think the bottom line is that space weather is ours to define. And I had this idea that we as a community could come up with a, RNC-style set of talking points that we all go on Fox News and talk about. An N-prong
We don't even have to say the same thing all the time. The opposite thing. Depending on who we're talking to,
That's right, talk on top of each other, that's good.
Monitor the wall.
I mean, and then imagine that, like we all have that calling card that we carry in our wallets, and we adhere to this tenaciously and religiously. I don't know, maybe that's a useful thing, right? So we are the people that own this set of ideas under the umbrella of space weather. I had this thing about, I know that there are those, as Teresa mentioned, there are those that are going to want to do highly capable monolithic observatories in our field, and they're going to feel like they're in a battle with those that want to do distributed sensing of some sort. And the only hope for this community is that we figure out a way to bridge the two, and that's not that hard. But we, obviously comes down when the rubber hits the road. It's about funding and things. But one way to maybe think about it is a chart that looks like this, where dimensions of geospace sampling. You can do better spatial sampling, which is a DAISY idea, optical magnetic radar. You can do small satellite formations and do that sort of thing from space. There's a capabilities axis, which is 3 examples here are like heart reinvigoration, whole atmosphere LiDAR, solar wind magnetosphere radar kinds of ideas. And then there's this problem of continued operation and maintenance that we run into. So there's sort of 3 things to think about that might be useful. And that's all I really actually have. I would leave this with the final thought from France Gordon. I don't know why I put the S there. I'm sorry about that. That was just writing too fast. My daughter's middle name. Merging ideas, approaches, and technologies from widely diverse fields of knowledge at a high level of integration is one crucial strategy for solving complex problems and addressing complex intellectual questions underlying emerging disciplines like space weather. She didn't say that last part, but
But the goal is to get her to.
yeah, the goal is to get her to add that. So those are my thoughts to start this meeting off, and I hope everybody can take the charge of trying to make this a little bit different and very discussion-oriented, perhaps argumentative even, sort of meeting. And I'll turn it over to Mike, who's going to tell us a little more detail about space weather
action plans, bills.
Did you really want to interrupt?
Sure. Well, while he's changing over, for sure.
Okay, so this may be a contrary view to a couple of things that have been said so far. I mean, I would say that, for the Advanced Technology Solar Telescope, and I can never pronounce the senator's name, I'm sorry, from Hawaii, but if you applied these criteria to that project, it could never have happened, right?
Which criteria in particular?
Well, for instance, appealing to all of the geosciences director, right? Because most people in our community don't even know much about it, right? And I think one of the things that we should wrestle with in this meeting is the fact that $350 million is actually not as much as we think it is, right? And if we try to address the whole system with $350 million, or try to come up with something that's kind of a panacea for everything in our system, we will just fail abysmally. That $350 million is something that we can do something that would address a pie slice of what we do, right? But not everything.
But that project came out of a different division of the NSF, ultimately. So with different concerns. They're used to big glass, right?
Yeah.
And then it was, anyway.
Yeah, and the second point I would make is that you had asked if we come up with scientific questions that would excite or inspire the public.
Yeah.
And I think I've thought about that a lot over the years, and I'm not sure that we can, right? I mean, if you look at the Hubble Space Telescope and the images are why the Hubble Space Telescope, excites the public.
Yeah.
I don't think people would, they can say, where did we come from? That's sort of the base level question that people associate with astronomy, having a wireless gear kind of thing. Right? I mean, the public actually likes images. I mean, solar guys have done a great job of exciting the public by showing them images of movies. So I think, as opposed to posing questions to excite the public.
Yeah, so my counter to that might be that that's not the only thing the public cares about. The public is interested when we find fossils of Lucy.
Yeah.
And the public is interested in things that are origin related. We can own that, right?
Yeah, absolutely.
We agree with that as
Yeah.
part of it. And you have a movie like The Martian, and they try to get the science right. I mean, that's right. That science is right in our wheelhouse too. So the public is interested in survivability in space, habitable environments in other places. Not to keep citing movies. I mean, Interstellar. Let's go through the wormhole. Whatever. It's I think there are other. I agree with you, but I think there are other things the public are interested in besides just images. Yeah, I am saying that.
A Hollywood movie.
Better than the several that have already produced.
Yeah.
So there will be some time for further discussion at the end of this. So why don't we let me get through my quick little presentation, and then we've got a chunk of time for discussion, and we can move into that. And as Therese and Josh alluded to, there has been significant attention at the highest levels of government for space weather. Coming out of the Office of Science and Technology Policy is the so-called National Space Weather Strategy, and in the United States Senate late late in February, March timeframe, there was a bill introduced for the Space Weather Forecasting Improvement Act, and we're expecting a companion bill to this to be introduced into the House next week that mirrors this, that increases the probability, as you all remember from your Schoolhouse Rock videos, that both houses have to pass it and then come together and sign it and get it signed by the president to become an actual law. So having a companion bill in the House is a good thing. And just alluding to the significant national attention beyond this, I was recently in Disney World with my family, and we were on the bus back from Epcot to the hotel, and the bus driver was talking to somebody in the front of the bus about how the solar flares are going to wipe out all of the communications and the technology, and I'm like, my work is done. You didn't get the solar flare CME connection quite right, but if the bus driver in Disney World can be concerned about it, we've got some attention, we've got some interest on the public scale that we can translate into things going forward. Okay, so just a little bit of a summary, trying to break down the Space Weather Strategy and Action Plan, and a little bit on the bill. The Space Weather Strategy and Action Plan comes out of the Office of Science and Technology Policy, which is run by the President's National Science Advisor. Is the person that's doing that, John Holdren, that's there, and this was developed through the SWARM, the Space Weather Operations and Research Mitigation Task Force, I think. It has the coolest, probably one of the coolest acronyms in government at the moment, but I may not be getting it exactly right. With a lot of leadership from Bill Murtaugh on detail from NOAA over to OSTP to get this thing forward and moving it there. It identifies 6 strategic goals that range from finding the benchmarks to identify what exactly is a big space weather event, to how do we respond and recover, to the key things for us on the improvement, assessment, and modeling of impacts, and advancing space weather services through advancing understanding and forecasting. And the action plan lays out some detailed specific goals and timelines that the agencies from NASA, Department of Commerce, NSF have to respond to in relatively, some are shorter, 6-month, 1-year kind of time frames, extending beyond that. The key one for us here in this room, in my opinion, is this goal number 5 for advancing and understanding and forecasting. And the key items from the strategy here are the need to establish what the baseline observational capability for space weather is, and what are the optimal mix of ground and space-based measurements that we need to do to be able to monitor this thing we call space weather. And I do agree with Josh that we have some flexibility in there in defining what space weather is, and we should be exploiting that to our advantage. And then in the action plan, there is a series of things that I've sort of copied and pasted into here. The availability of facilities for the calibration of things, the development here, this is the key one for us in my mind, the development of novel sensor technologies and instruments to improve forecast lead time and accuracy. Maybe everybody in this room doesn't want to be in the quote-unquote operational forecast lead time and forecasting improvement game. But if we can tie ourselves to that, we've got attention at the national level, at the congressional level, that can translate into information to Franz Cordova, to Steve Clark, to others, to move this ball that we all want to do in the discovery side of things forward. And there's a really big hook for being able to do that with that from there. NSF and NASA continue to do operation research development and enhance the understanding of space weather, the key things that are within the Geospace program here, and the basic research opportunities to understand how the solar processes and the activities drive changes on Earth and the nearer space environment. There's a lot of space within these things to drive what we want to do, but I think a real key point here is to make the connection to the space weather, because that's got the attention at the national level that we need, that we can translate into monetary support. The Space Weather Research and Forecasting Act is Senate Bill 2817. That's an important number to remember and love, because when you talk to your staffers at Congress, that's the thing that they can go look up and find quite easily. It is actually a bipartisan bill introduced into the Senate, as I said, in March by Senator Peters of Michigan and Senator Gardner of Colorado, as well as Senator Booker of New Jersey. A key thing you'll note on this is that there are 2 Democrats and a Republican introducing this, and that bipartisan support is pretty hard to find in Congress. I've made several visits to Congress over the past months to talk about this thing, and it's remarkable, from the most conservative member of Congress to some of the more liberal members of Congress. There seems to be a willingness to get behind it, and space weather seems to be a bipartisan issue, and we can do that. As is evidenced by the fact that this bill was passed unanimously out of committee on the 29th of April. There's not much that gets out of anything unanimously. It's up right now for consideration in the Senate to be passed by unanimous consent. There are 6 million ways that could go wrong, ranging from somebody being angry at somebody else to objections of a more substantial nature. But we're trying to move that ball forward there. We're hoping to get the bill that will be introduced on the House side to have sort of a mirror image of this, where we've got a Democratic congressman and a Republican congressman doing co-sponsorship of the introduction, so that we can continue this bipartisan effort moving forward. But we've got a space weather action plan and strategy, and for the most part, this bill is pretty much take the space weather action plan and strategy and put it into there. Why do we need that? Well, we need that to maintain the continuity. As has been indirectly alluded to, there's an election coming up in November, and regardless of who wins, there's going to be a transition in administrations, and we don't want the attention that we've got on the executive side to go away. If we can get that mirrored into U.S. law, it gives us a continuity going forward and moving that forward there. It has tasks for the National Science Foundation to provide data for space weather ground-based observations, including pretty much everything that people in this room do, and for NASA, DoD, and NOAA to support, along with the NSF to support research. Not maybe directly applicable to the Quo Vadis instrumentation things that we're talking about here, but the sense of Congress that NSF and NASA should support the heliophysics science centers. As a modeler, something that we want to be thinking about from the observational side is how do we feed the observations that we're getting in here to make the next generation of space weather forecast models that can provide improved forecasts and a better understanding of the systems. Formal mechanisms for transitioning these things into operations, and to improve the key language from the action plan of improving the forecast lead time and accuracy there. So what are the next steps? From my perspective here, as I've alluded to, getting this kind of attention is really hard to do. It's a once in a lifetime kind of opportunity, and I'd hate for us to miss it. We want to be able that we can attach the things that exciting new instrumentations, new things to the plan and move it forward to get the support that we want to be able to do it. We can do that with both the observations and the modeling side of things. The one thing you haven't heard me talk about is money. Dollar amounts. Neither the action plan nor the bill have significant statements of spend this amount of money to do X in it. However, that's mainly because they're on the sort of the authorizing side of things. The Space Weather Action Plan has translated into advice to the agencies from John Holdren for the science agencies to prioritize space weather in the development of their budgets. So that's an important aspect of these kinds of things. And if we get the bill passed, it gives us an action to be able to go back to the appropriating committees and say, hey, you told us we have to do this, so give us the money to make it happen. It's a long game, but it's a game that we want to be engaged in to move forward. So I'd urge everybody in the room to think about the possibility of educating your senators and representatives about these bills. I have a one-pager that's a nice little summary of the thing that I can provide to anybody that's interested that you can use as a leave behind or email to your person and go forward with it from there. Yes, sir.
When you say the we, I'm not sure who the we is, but I know that Andy Gerard at NCAR has been talking to Boulder. And I know that UNH in New Hampshire, been talking with
So actually, that's a great point. I forgot to mention that when I put these slides together late last week, I didn't know this, but Jean Shaheen has actually just signed on late last week as a co-sponsor of the bill in the Senate. So we're, the connections that people are making are having impacts and moving these things forward. But that's what we want to be able to do, is to get everybody aware of it. Yes, sir.
One of the things that bring people together and unify is threats.
Uh-huh.
And just talking with students and PhDs, many of them are sort of leaving the field. They're going somewhere else. Is that part of the sense of our Quo Vadis, is if we don't get together and take advantage of this once-in-a-lifetime opportunity?
Yeah, I mean, I think that's what we want to be able to do, is make sure that we've got an exciting field that we're bringing some of the best and the brightest minds into, that they can see that there's a pathway forward, and we're doing cool, new, cutting-edge science to bring it there. And I think that's what we, that's the Be Spectacular message from Therese, in my opinion.
So I think that's important to be able to convey the excitement and the new directions opposed to the
Absolutely.
human.
So Mike, are you thinking about the kinds of written, not documents, but really policy-oriented kind of articles that would appear in Physics Today and other kind of journals that really would hit the press at about the right time after the election, and as the administration thinks about new initiatives coming on?
So we're certainly thinking about trying to make sure that we've got briefings and things that are lined up for the transition. Putting that into Physics Today or some kind of article like that is not something that I had thought of, but it's a good idea.
I think it's important for rallying
Yeah,
the community,
yeah.
and it's also important for stating clearly why we are a discipline worthy of.
Right.
The public could resonate with us.
Yeah, no, that's a good point. Dave, do you want to complete the inspiration and tell everybody why they're here?
So yeah, so I've been tasked with giving people the charge, and views of Teresa's slides, I would simply say charge. But I didn't know that was coming. So the organizing principle of that the organizers have had for this whole thing is that we've all been to meetings of the SDA, and we didn't want this to be that. And so we're calling upon you to, how did that get up there? And so we're calling upon you to help us make this something a little bit different. And I think that the meetings that we attend, they are the way they are because people want the outcome that they have. And the normal outcome is, Oh, I'm sorry. Sure. So I think the meetings that we regularly attend are the way they are because they have the outcome that people want, which is people giving status reports about their science projects, and that's not the outcome that we want here. We want something different, and we really need everyone to sort of be on board with helping us get something different. And so I'd like to propose sort of the overarching question for our speakers, and it's a simple one, and it's given the resources, what can we do as geospace researchers to have impact, to have the most impact? It's as simple as that. And what might the instrumentation look like? And this question just leads to more questions. Who is us? What is impact? And what about that instrumentation stuff? And so first of all, I want to talk about the fact that the first thing that we've done here is we brought together people who don't always sit together in the same room. And what we're trying to do here is germinate the kind of community that we're going to need to go forward and to go down this path. And my own view is that the delineation, solar, mag, and aeronomy has served a great purpose, but it's not going to carry us forward. And in order to actually pursue the research that we want to do here and to pursue the resources that we're looking for, the stovepipes have to come down, and we have to think about integrating, not just across these communities, but even further than that. My dean has no idea what these terms mean, and will not hire in these areas because they're meaningless. And our students don't know what these terms mean and aren't really falling into the field. They have no idea what these things mean. But I think, geospace might mean something. And space weather might mean something. And I think we could all be part of that. I've learned from my geologist friends that, my geologist friends have professional mathematicians and applied mathematicians and computer scientists in their team. And we tend to be sort of self-contained. We don't do that. And that's actually a little bit unusual. And I think it's going to be essential that we integrate better if we're going to kind of have the kind of impact that we want. As far as impact, I think Pasteur's quadrant is as good a way as any to look at impact, and I think it comes down to discovery research with meaningful application. And so I want to say something about that. And then I want to talk a little bit about instrumentation. So as far as community goes, I mean, the first thing we're going to do when this workshop is over, I think, is we're going to try to set up a means of having follow-on workshops that are going to delve into more detail, and we're going to approach this through the prevents solicitation, which right off the bat is calling for interdisciplinary and cross-disciplinary proposals. And so it just simply wouldn't fly for astronomers or mag or solar physicists to go after this by themselves. And in the end, we're going to be tasked to do something much broader than that, to seriously pursue an MREFC. We're going to have allies across the division and outside the division and outside the directorate, including natural allies like we might find in NPS and so forth. And this is really new territory for us, but I think it's something that we can start doing right here. And this could be the genesis of a different group that more able to pursue the goals that we're setting out for ourselves. As far as impact goes, I think that Pasteur's quadrants is a perfectly fine way to look at this, and that we should be thinking about basic research and discovery research, and at the same time, applied research that is actually really meaningful, that actually really works, that actually has implications for people outside of this room. And as the example of the basic research, I wanted to show you this. I was actually preparing my remarks back in February when this story came out. So this is LIGO, this is the gravitational waves. And I just couldn't believe this when this happened. I was surprised at how surprised I was. And at one point I taught a course in modern physics. And modern physics is when you take some undergraduates and you expose them to sort of the greatest discoveries of the 20th century. You expose them to Rutherford scatter and Michelson-Morley experiment and the beginnings of quantum theory and relativity and so forth, photoelectric effect, and then you sort of tease the students and tell them if they just stick with it, they'll really learn about all these things. And I enjoyed teaching that material, but it was like teaching a history class. It was like teaching a history class. These things were happening in many cases before people had electricity in their homes and so forth. And so for something like this to happen, and it made me think, my goodness, this is on a par with that. This is as significant of a finding as has occurred in my lifetime by a lot.
Dave, by the way, there's a Python notebook with the data.
Is that right?
It's very, very interesting.
There you go.
It's really magic. They just basic signal processing
and so, I remember, the sounding rocket program at one point coming under fire from a NASA executive who said, oh, they just produce squiggly lines. We can't sell that kind of stuff. But look, no imagery, no movie, squiggly lines. Squiggly lines. And this is as good as I've seen in my lifetime. And it really made me think, that's ambition. Could we do something like that? Could we have that could we telegraph what we're doing? Something like that. Now, you may say,
Well, they sold that to the public as an audio form.
There you go.
They made music out of it.
There you go. So we can be creative and reach people. But I think that the message in its own right didn't need to be dressed up too much. And now you may say, oh, that's fine for cosmologists. That's fine for those folks. They can reach that high, but we can't be that ambitious. We'll do something not as grand. But I hope you're wrong, and I think you're wrong. And I think that it's going to be necessary to at least aspire that high if we're going to pull this off. And then as far as the other part of Pasteur's quadrant, I mean, this is something LIGO didn't have, right? LIGO can't appeal to applications for use. I mean, I could be wrong. I mean, it could be that the telecom providers are going to be fighting over gravitational wave spectrum in years to come. It's possible the vibrator on your phone will actually be the antenna one day, but I doubt it, at least not too soon. But it looks as though something's really fallen into our lap here, because this is This is a discipline waiting for a community to inhabit it, waiting to claim it. I think that if we could come together and say, we will solve this problem, we'll take this on, we've got this covered, people would love us. We would have fans, we would be celebrated, and we might actually see some resources. And I think Mark's comments are also sort of right on the money here. Mm-hmm.
I think it's very important in doing that not to convey the impression that, yeah, you give us a 5-year plan and we'll solve it. Because after all, the National Center for Atmospheric Research have been in the tropospheric weather business for a long time. And it's very likely that the kinds of things that we do will go on for a very long time. We shouldn't try to tell them
The dilemma is it better be real, but it better be important.
We need something short term, but we shouldn't try to say that we're going to solve the whole thing.
And by the way, as NSF, I think what we're looking at is the research aspect of this, not the operational aspect of this. But it had better be real, and we better identify what the problems are. So, for example, we're being told at Cornell that DoD has already decided that GPS will be the first thing to go in any kind of a conflict, and they're not expecting it to be reliable. And we have research projects all over the campus looking at alternatives. So we'd better make sure that the space weather dilemmas that we're posing are real ones.
So I think you have to be careful because we're trying to walk a balance between Trump and Clinton. We're all going to die because the power's going to go out. That's the Trump message. You don't need any detail. And then they'll say, well, we really need all this detail to do the physics and understand this complex system. That's two completely different audiences and we need both. So somehow we have to bring these theories and acts together with the science for a crystal clear message that applies to the Trumps and the Clintons. Those two extremes. And so that thing, if we can at least get some handle on how we can approach that problem in this route, I think that would be a big step. Given everything everybody else has said is all important. We need the funding, we need the implementation, we need the fundamental research, we need to apply it. But we have to get that message across. And I think we'd be fooling ourselves if we think there's one audience, one message for that whole audience. And we really need to find the right path.
Yeah, absolutely. I think that's well said. Aaron?
So the way the weather community works is that they sell missions and everything by looking at, how is a hurricane going to develop? It's a rare event and everything, but it's important for people's lives and safety and everything. And then we look at tornadoes and stuff like that, which are also rare events, but these things would kill people and stuff. But everybody in this room really just wants to know whether they bring a jacket to Boulder, right? And so that's sort of like we use these large events to motivate, but then really what we do is provide like day-to-day type of stuff, and then how can we improve your day-to-day forecast?
Yeah, well, fair enough. So lastly, if we play our cards right, then there's the small little detail of actually building the instrumentation. And Jeff Thayer pointed out this morning that from time to time NASA drops a big gift in our lap, some kind of a major mission or even an explorer. And when that happens, it's catalytic, and it sort of propels us forward to the next generation of discovery. And but those are space-based instruments, and NSF largely is doing ground-based instruments, and we should recognize that they're complementary and that there are important things that have to be done from the ground too. And so I just made a list, and we could make different lists and compare them and so forth. And the atmosphere is vertically stratified, vertically profiling is important, the sampling is different. Ground-based instrumentation tolerates an awful lot more risk than space-based instrumentation in the main and so forth. But I think the biggest contrast is NASA launches space missions as a consequence of a process, and it's a very deliberative process. And we know how that works, and it's enormous and all-encompassing and so forth. The facilities program that we have did not come about as a consequence of any kind of strategic planning whatsoever. We just have it. And it came about through a number of historical, accidents. Maybe that's not quite the right word for it, but it never came about as a consequence of a strategic process. So we have been reviewed and surveyed and mapped and steered within an inch of our lives, and yet I can't remember in my lifetime a group of people this large ever getting together to talk about, forging the future of our facilities. It's never happened, at least not since I've been in the field. And I think that's remarkable that we're here with that task. And so I think that is the task. And so I'll leave you with it. And the other thing that I want to point out is that this is sort of a 10-year time horizon. And so if you have an idea you want to talk about that you think you might kind of mop up in the next couple of years, that's probably not it. And also, we're really talking about the very largest basket of resources that we can go after for ground-based instrumentation. And so there are many ways to get certain kinds of instruments supported, but the flagship instruments, there aren't too many ways, and so that should be an important component of what we're talking about. So I'll leave it there. The mechanics of this workshop are going to start out this way. We're going to ask people to come up and give their presentations. We're going to time them carefully and threateningly. And when you completed your remarks, we're going to not ask for applause, and we're going to not take questions during presentations. When you've completed your presentation, please have a seat at the table. And when the table is full, then we'll have a panel, and that will be the place to really have it out. So it's a kind of a different dynamic, and we'll see how it works. But that's where we'll have questions and debates and discussions, and we'll try to get through the program. And we'll see if it works. So let's see. With that, who's first? Guess God is first.
So no interruptions?
No interruptions, particularly from you.
You guys say something?
I was just going to ask people to give me their talk.
All right, go ahead.
Yeah, so especially if you're in the next session and you haven't already gotten your talk up here, there's the wall of shame for people that haven't gotten their talks into the drive here. If you haven't given it, please see me so we can get everything on one laptop. In order to get through the presentations in a timely fashion, we want to do it all from one machine. So we'll be taking a break shortly, and we can, if you can see me and give me those, that would be very helpful.
Yeah, and so before that break, I'd like you all to stand up and greet 3 people around you, just to say hello, because you may never have seen them before in your life.